Day 12. We continue our work analyzing functions, looking at their graphs. So this is we're covering a variety of function-related vocabulary: domain, range, end behavior, x-intercepts, y-intercepts, zeros, that type of thing. So all the notation and vocabulary pertaining to functions, that's what we're dealing with. Okay. Let's see. The domain. Domain is the x values represented by a function. So this particular graph and the way it runs to the edge of the graph like this, we're supposed to assume that it keeps going like this forever. So the domain is how far left to right it goes. Well, this graph goes left forever and right forever. So that's negative infinity to positive infinity. The range, all right? The range is the y values represented by a graph. So for that reason, the range is going to be bottom to top, and it's got to be in that order, least to greatest, bottom to top. The bottom, this has a bottom, okay? It's not negative infinity. The bottom value is right here. So the range is going to begin at -4. And then it goes up forever. So it's -4 to infinity. Notice we put a square bracket on the -4 to show that the -4 is included. It touches -4. It gets all the way there. Now, end behavior. In words, we would say on the left it rises, and on the right it rises. But in symbols, in mathematical symbols, instead of saying on the left, we say as x approaches negative infinity. Okay, that's a fancy way of saying as we go to the left. All right, as we go to the left, it rises. So to say it rises, we say f of x approaches positive infinity. Okay, so everything in red here is always the same. As we go to the left, the function, and if it rises, we put positive infinity. If it falls, we put negative infinity. So I'm putting this in blue because that's the only part that changes. And again, we want to say on the right, as we go to the right, it also rises. So instead of saying as we go right, we say as x approaches positive infinity. Now we want to say the function rises. So we will say f of x approaches, and again it's going to be positive infinity. Okay, rises, rises, rises. If it had gone down, we would have put negative infinity, and that's the only thing that's really changing. Okay, so that's the end behavior. Now, in general, we have this. F of x is equal to y. So if you see a number inside of the parentheses in this notation, that's telling you that that's the input, that's the x value. And you're being asked for the y value that goes with it. So looking at this graph, if I say find f of 2, is this 2 an x value or a y value? Well, this 2 is in the same spot as the x. So this 2 is an x value. And so you're being asked for the y value. All right, let me check something. Okay. So if 2 is the x value, that means, look, go to an x value of 2, and then look around and see where the function is. Well, this one's a little strange, because if I go to an x value of 2, I look around and I see the function is right there. It is the x-intercept, but you have to realize that the value in that case is 0. So I went over 2, but basically the y value here is 0. So f at 2 equals 0. Okay? So as an ordered pair, I could say 2 comma 0 is what I'm dealing with, 2, 0. Now, f at 4 equals. I'm sorry, negative 4. Again, this is the x value. So if the x value is negative 4, that means go to negative 4 on the x-axis. And then look around to see where the function is. So if I go over to negative 4, if I wanted to get to the function, I would have to drop down to here. Bam, negative 4 is the x value, but the y value that goes with it is negative 2. Right? You can see that right here. Okay, so the x value is negative 4, the y value is negative 2. Okay, x value here, y value there. All right, x value here, y value here. Okay, so f of negative 4 is negative 2. It's the y value. Or if I asked you to write me an ordered pair for this, you would put negative 4 comma negative 2, x comma y. All right, kabam. Now, for what values does f of x equal negative 2? Now, remember this, what I told you, f of x equals y. So when I say f of x equals negative 2, is this negative 2 an x value or a y value? Well, hopefully you can see that this negative 2 is in the y position, all right? So this is a y value, okay? So you're being asked for the x value that goes with it. So, and it could be more than one. So if negative 2 is the y value, that means go to a y value of negative 2. Sorry, go to a y value of negative 2 and look around. I feel like I shall change colors now. Alright, so if I go to a y value of negative 2, that would be right here. Now as I look around, I see that there are 2 points at this y value, okay? Basically, I could draw a horizontal line at negative 2. And if I did, I would realize that there are 2 x values of the function at negative 2 on this green line. And it's here and here. So you're being asked for what x values do you get this y value. So at the y value of negative 2, I have the following x values. Well, I already have one of them even drawn. Well, okay, I guess I have it labeled with a y value. I'm talking x values now. So this is negative 4, all right, x value. And this one has an x value of 0, because it's right on the line. So negative 4 and 0. All right, that was tough for some kids. So hopefully you understood that. X-intercepts. So this graph has 2 x-intercepts, which I will show as purple. All right, we have an x-intercept here, and we have an x-intercept here. X-intercepts should be written using ordered pairs. So this first x-intercept is negative 6 comma 0. And this one over here is 2 comma 0. Now the y-intercept, which I will show in this pinkish color, the y-intercept is where the graph crosses the y-axis. So that's right here. So the y-intercept is 0 comma negative 2. All right, intercepts should always be written as ordered pairs. All right, now number 9. Is there an absolute maximum? Okay, is there a single point that is the highest point on the graph? Well, the answer to that is no. Okay, there is no maximum. Because this graph goes up and up and up forever. All right, so there is no maximum value. So there's no absolute maximum value. Now, is there an absolute minimum value? Is there a single point that's the lowest of this entire graph? Well, there's one right here. This is the absolute lowest value on the graph. So yes, we have an absolute minimum at negative 2, negative 4. Okay, what about a relative maximum? All right, that would be a maximum. That's the highest point in a certain area, but it's not the highest point overall. No, there's no relative maximum either. If this graph looked more like this, here's an example of a graph that would have a relative maximum. Okay, say if it was doing this. Okay, and say if it did go up forever. Well, in this case, this spot right here would be a relative maximum because it's the highest point around this area. If I go to the left, I'm going down. If I go to the right, I'm going down. It's at the top of a hill. But it's not the highest point on the graph because any of these points over here are higher still. So this would be a relative maximum. But there's no point like that on this graph. All right? There's no hill anywhere. Okay, let me erase that. So we will just say no, or no, none. What about relative minimum? Well, we have a minimum, but it is the absolute minimum, so we're not going to list it twice. So we'll just say none. There's no relative minimum, just the absolute minimum. All right, let's talk about the increasing intervals and the decreasing intervals. The increasing intervals are going to be the parts of the graph that are going uphill. Increasing will be uphill from left to right. Decreasing will be downhill from left to right. Please understand that we only are looking for the x values. So let me color this to make it clear. If we were walking this path, like walking along a trail, we would find ourselves going downhill for the first part of the journey. All right, we'd be going downhill, downhill, downhill. And then right there it switches, and then all of a sudden we're going uphill from there on. Okay? Now the red part of this graph is the decreasing interval because I was going downhill from left to right. And the green part of the graph is the increasing interval, uphill. But again, only the x values. Only the x values. Okay? So take a look at this. Let's see. I'll do blue. This is the point, all right, x value wise, here's where it switches from downhill to uphill, okay? Right here. All right, this is -2 that I just scribbled over. So, this goes to the left forever. So, starting from -infinity, okay, this thing was going downhill since -infinity. And it continued going downhill all the way until we got up to -2. Okay, so that's why we have a decreasing interval. Let me jump over here from -infinity to -2. Now, I will use a round parentheses on the -2 because right at this point, it is neither increasing nor decreasing. All right, that's just the point where it changes. Okay? And then it switches and it's increasing from there on. So the increasing interval goes from -2 and then it goes forever. So from -2 to infinity, it's increasing. Again, I will use a round parentheses on the -2 because again, at -2, it's neither increasing nor decreasing right at that spot. Okay, so from here on, -2 to infinity. X values, that's why -2. So a common mistake is kids will want to put -4 to infinity or something because they want to do the y value. So if you put a -4 in there anywhere, the problem is this is a y value. You have to look at the x value, not the y value. Now the domain. The domain, again, is the x values, so it's how far left and right the graph goes. This graph goes left forever and right forever. So the domain will be -infinity to +infinity. Okay, the range. The range is the y values of the graph, bottom to top. Well, this graph goes down forever and up forever. So that's another -infinity to +infinity. Now the end behavior. On the left it rises, on the right it falls. So we will write that this way. As x approaches negative infinity, in other words, on the left, f of x approaches positive infinity. Okay, that means it rises. So on the left, it rises. And then we'll say as x approaches positive infinity, f of x approaches negative infinity. All right, that means as we go to the right, it falls. Okay, that's the going to the right, and that's falling. Now, find f of 1. Again, this is an x value in there, so go to an x value of 1 and look around. Well, if I go to 1, the graph is right here at 0. Okay, so f at 1 is 0. As an ordered pair, that would be 1, 0. Find f at negative 1. Okay, if I go to negative 1 and look around, bam! At negative 1, the function is here at 2. So that means f at negative 1 equals 2. Or as an ordered pair, I could say negative 1 is matched up with 2. Okay, now the zeros of the graph. The zeros come from the x-intercepts. You look at the x-intercepts for the zeros, but you do not write an ordered pair. If it's zeros, they're just numbers. Okay, so the zeros are here and here. But for zeros, we do not make an ordered pair. So we will just say negative 2 and 1. Those are the zeros. All right, no ordered pairs. Now, y-intercept is always an ordered pair. So here's my y-intercept, 0, 4. Absolute maximum. Is there a point that is the absolute highest point on the graph? No. There is no absolute maximum because this graph goes up forever. All right, what about an absolute minimum? Is there an absolute minimum? Is there an absolute lowest point on this graph? Again, no. This graph goes down and down and down forever, so there is no lowest point. So absolute minimum, none. Now, how about a relative maximum? Okay, a relative maximum, it's not the highest point on the entire graph, but it's the top of its own little hill. And here's a relative maximum right here. Okay, it's not the highest point on the graph because like these points over here are higher, but it is the highest point in this area. So that is the point 0, 4. So yes, I have a relative maximum, 0, 4. What about a relative minimum? Do you see one of those? Yeah, there's a relative minimum right here. All right, it's the lowest point on the valley here. So that's negative 2, 0. All right, if this had been the lowest point overall, I would have called it the absolute minimum, not the relative minimum. Okay, so now we will talk about the intervals of increasing and intervals of decreasing. Now, when you see increasing, think uphill. Decreasing is downhill. So imagine yourself walking along like you're going on a journey from left to right. It has to be a left to right journey like this. Okay, you're trying to get from this side to this side. But you come to here, and now we're going to follow this path. Everywhere you're going downhill is going to be a decreasing part of the graph, and everywhere you're going uphill is going to be increasing. So as we go from here to here, I'm decreasing. Okay, so this part of the graph is decreasing. Okay, until I get to right here. And then suddenly, you turn, and now you're going uphill for a while. So that's increasing. Okay, and then you get to the top of the hill, and then you start going downhill again. And you wind up going downhill for the rest of the time. Really, forever. All right, so we have two decreasing parts of this graph and one increasing part. Now, be careful. When we talk about the increasing and decreasing intervals, we want x values, only the x values. So the increasing part of this graph goes from here to here. But all we care about are the x values, okay? So as far as the x values, it goes from here to here. That's -2 to 0, x values. All right, so when you do the increasing interval, you're going to say it goes from -2 to 0, okay? From here to here, really. Okay, like from here to here. All right, now, I want to be real specific about whether or not I'm going to put square brackets on this or the round kind. And guess what? I'm going to put the round kind on this, and here's why. Right at the turn, all right, I'm decreasing, and then I turn, and then I'm increasing. But the key is right at the point, right at -2, where I switch from decreasing to increasing. At that point, I am neither increasing nor decreasing. If you were thinking of slope, this is downhill, this is uphill, but the slope right at this relative minimum is 0, neither increasing nor decreasing. Same thing up here. I'm going uphill, I'm going downhill, but right at the point where it changes, it's neither. It's neither increasing nor decreasing. If you were to take a look at the slope, it would be horizontal. It's neither uphill nor downhill. So that's the key. Because it's not increasing at those endpoints, then those endpoints cannot be included in the increasing interval. So we show that the ends are not included using round parentheses. Now let's look at the decreasing intervals. The decreasing intervals I've shown here in red, well, really sort of a pink. And it starts, remember, this goes forever from the left. So that starts from -infinity, because remember, we're talking about x values. So x value wise, this starts from -infinity, and then it goes and goes and goes until it gets to here. Okay, so it goes from -infinity to -2. Okay, so we'll say -infinity to -2. All right, and again, we will use round parentheses to show that the -2 itself is not decreasing anymore. And then it picks up again at 0. So it goes from here to, positive infinity. All right, because remember, it keeps on going and going and going to the right. So it's going to be decreasing from here forever to the right. So 0, remember x values. We need x values now. So we need 0 to positive infinity. Okay, so we will say 0 to positive infinity. Again, we'll use a round parenthesis to show that 0 itself is not decreasing. All right, that is how you do increasing and decreasing intervals. All right, and oh, well, there's a back, man. I thought I was done with this video, you guys. Yeah, imagine how we feel, Burton. Okay, you got me. All right, let's go ahead and do the back. It's going to be time for lunch pretty soon here for me. The domain. I'm going to speed up a little bit because I thought I had more time. Thought I was done. The domain is how far left to right the graph goes. But this graph goes left and right forever. We're supposed to assume that it keeps going when it hits the edge of the graph like this. So the domain would be negative infinity to positive infinity. Now, is the range also going to be negative infinity to positive infinity? I would say no, because the range is the y value. So for the range, we're talking how low to how high does it go, bottom to top. And the bottom of the graph is right here at 1. So it does have a bottom. So we're going to say 1 to infinity. Okay, the bottom is at 1 and then it goes up forever. So there's your range right there. And it has to be in this order, bottom to top, 1 to infinity. Okay, now for what x values does f of x equal 6? Remember what I told you on the other page. The idea is f of x equals y. So if I put a number here, it's an x value. If I put a number over here, it's a y value. So this 6, is this an x value or a y value? All right, this 6 is a y value, you guys. That is a y value. So I need to go to a y value of 6 and then see where the x's are. So here's a y value of 6. Okay, now if I look around at this height, I see an x value here and I see an x value here. These x values are at -1 x value and 9. All right, and these are both x values of -1 and 9. And that's what they're asking us for, x values that give us this y value. So you should just list them, -1 and 9. Okay? Or you could say x equals -1 and 9. Now, just like we did before, the increasing and decreasing intervals, but this time I'm going to do it fast. All right? The graph is increasing from here up. Okay? That's increasing. The graph is decreasing from here down. All right? Because from left to right, it's downhill, uphill. Decreasing, increasing. So the increasing interval is, and remember, we want x values now, only x values. So it's increasing from here over. So from 4 to infinity. So increasing, that's 4 to infinity, and they should both be round. Okay, and then decreasing, it's going to be decreasing from here to 4. Okay, all in this area, from -infinity to 4. So -infinity to +4. And again, keep it round because right at 4, it's neither increasing nor decreasing. Okay. End behavior. On the left, it rises. On the right, it rises. So, as x approaches -infinity, that's on the left, f of x approaches infinity. It rises. As x approaches positive infinity, that's on the right, f of x approaches positive infinity. It rises again. Rises, rises. If it fell, I would put -infinity. Okay. Now the review problems. All right. These are like problems that you guys had on that last quiz that several of you didn't do so well. So make sure you can do these problems without the video. So if you've got a pencil in your hand, please put it down. Put the pencil away. Do this by yourself. Okay. Let me zoom in. The first step of factoring is to look and see, is there a common factor? And I'm seeing the 0 and the 5. Look guys, both of these are going to be divisible by 5. So we need to pull out that GCF. Okay, pull out the 5 outside of parentheses. Now when you do that, you are dividing. So this is going to make 4x squared minus and I believe this is going to be 25. Yeah, 25. Okay, so I've got this. Hopefully, this jumps out at you as the difference of two perfect squares. So that means I can factor this further by doing 2x plus 5 and 2x minus 5. Okay, so that is now completely factored. All right, take a look at number 33. Hopefully you recognize this as the sum of two perfect cubes. The sum of two perfect cubes always factors as a binomial and a trinomial. The binomial is just the root of these things. Okay? A to the third comes from A. I just bring down the plus. 27 comes from 3 to the third power, so I put 3. B to the third comes from B. So this is your binomial, A and 3B. To get the beginning and end of the trinomial, I just simply square these. If I take this and square it, well, that's A squared. If I take this and square it, well, that's positive 9B squared. Don't forget the B squared. A lot of kids ignore the B for some reason. They ignore the variable. All right, this is 9B squared, not 9B and not just 9. That just leaves the middle. The middle, you multiply these together. So A times 3B, well, that's just 3AB if you multiply together. But you always do the opposite sign. So this will be negative 3AB, opposite sign. So to help us with the signs, we think about SOAP. This stands for same, opposite, always positive. This sign is always the same, this sign is always opposite, and this sign is always positive. Okay, that's how you do the sum or difference of two cubes. Now look at number 34. Again, the first step of factoring is to look for a common factor. These are all even, so I know they are divisible by 2. So let's do that. All right, now the 2 doesn't disappear, I put it in the front. So that's going to leave me with x squared minus 2x minus, let's see, 63. Now chances are this trinomial will factor, so let's give that a try. So as I factor this, I look at x squared, that can only be x times x. 6 times 3, I mean not 6 times 3, 63, the first thing that pops in my head when I say 63 is 7 times 9. Alright, so hopefully you know your multiplication facts so that that fact will pop into your head. I need a negative 2, so that means I need the bigger one to be negative and the 7 would have to be positive. You know what I mean? Inner, outer. Inner, I have 7x. Outer, if I have negative 9x. Together, that would give me negative 2, so that's what I want. Okay, and positive times a negative is a negative, so boom, there you go. We factored it. All right, what else you got? Looking at number 35, you see that it's 4 terms. When you see 4 terms like that, let's go for grouping. Grouping is where I take these two as a group and then I take these two as a group. And I do the common factor of both. For this one, the common factor is, let's see, I see the x, and they're both divisible by 2. So the common factor is 2x. So I will put, move it down a little bit. It's time for lunch. So I will put 2x, and then I'll put a parentheses. Now if I divide both of these by 2x, let's see, 6 divided by 2 is 3. X squared divided by x is x minus 16 divided by 2 is 8, and the x is canceled. So 3x minus 8. Now I'll look for the same situation over here. Let's see, 21. 21 is divisible by 3 and 7. Then I look at the 56. Well, 56 is 7 times 8. So both of these are divisible by 7. So let's pull that out. So I do my plus 7. And then now I'll do my parentheses. Okay? Now again, I'm dividing, so I'll divide both of these by 7. 21 divided by 7 is 3, so I'll have 3x. As I said, 56 divided by 7 is 8, so I'll have minus 8. Oh look, this is the same thing twice. This is a common factor. So the parentheses themselves have to come out front, and we're factoring out the common factor of 3x minus 8. So I will put 3x minus 8 out front. And then if I drag these away as 1, what does that leave behind? That leaves behind the 2x and the plus 7. Okay? Notice this is not squared. It's not 3x minus 8 squared. Alright? All I did was undistribute the 3x minus 8. I factored it out. Alright? When you pull out a common factor, it's sort of like when I pulled out this 2, because there was a 2 everywhere. It's just a single 2. It's not 2 squared, it's not 2 to the third power, it's just a 2. Same thing here. This is the common factor. Just pull it out once. Notice it is not plus. I'm mentioning these things because I saw this on the quiz. Some people put a plus in here, some people squared it. No, this is it. Alright, now, we're still not done. Okay, is this the last problem? Okay, 2 more problems, man. Okay, quadratic formula. Quadratic formula says that if this is in standard form, which is like this, ax squared plus bx plus c equals 0, then if it's in standard form, the quadratic formula says that the solutions will be opposite of b plus or minus the square root b squared minus 4ac all over 2a. That's the quadratic formula, and you need to memorize that. If you look at this, you notice that it is not in standard form. So you need to add 13x to both sides to make it look like this. So then that's going to give us 4x squared plus 13x plus 3 equals 0. Now it's in standard form. Now, I don't want you to go plug in. Oh yeah, I guess I should say this first. A is equal to 4, B is equal to 13, and C is equal to 3. Do not just go plugging in all the A, B's, and C's all over the place. What I taught you to do was find the part that's under the radical first. This is called the discriminant. And so always calculate the discriminant separately. So separately, we're going to do our b squared minus 4ac by itself, okay? So in this case, that's going to be 13 squared minus 4 times 3. All right, if you do that, okay, if you're going to do 13 squared in your calculator, please make sure you put it in parentheses. All right, minus 4 times 4, what was it, times 3? Let me double check. Yeah. Okay, we get 121. So the discriminant is 121. All right, remember that. We'll need that in a second. So as I go ahead to do the rest of the problem, then x equals opposite of b. So there's b is 13. So the opposite of b is negative 13. If b had already been negative, then I would have put positive. That's why I say the opposite. Plus or minus the square root. Now this is the discriminant. That's 121. Okay, all over 2a. Well, a is 4, so 2a is 8. So this is the beginning of the answer, but we just need to simplify this. Now 121 turns out to be a perfect square. The square root of 121, all right, is 11. So that makes this become x equals negative 13 plus or minus 11 over 8. All right, and then you need to understand that this is really two things. This is negative 13 plus 11 over 8, okay, and it is negative 13 minus 11 over 8, okay? Now some of you are bad with your addition and subtraction, but negative 13 plus 11, you know what? Negative 13 plus 11, not 133. Okay, that is negative 1/4. Okay, and then negative 13 minus 11 over 8. That is negative 3. So these are your final answers, negative 1/4 and negative 3. So you can't leave it like this, you can't leave it like this, you can't even leave it like this. You have to take it all the way down. Now if this had been like a radical 11, then I would have been done. But it's not radical 11, it's a plain 11, so you have to keep going. Okay, finally, this is the last problem. If I want to solve this by factoring, I need to subtract 49 from both sides. So that's going to give me 9x squared minus 49 equals 0. Hopefully you realize this is the difference of two squares. So this will be 3x plus 7, 3x minus 7. All right? But we don't stop. We're solving an equation. See the equal sign? So what we do is we set both of these equal to 0. 3x plus 7 equals 0. 3x minus 7 equals 0. If I subtract 7, I get 3x equals negative 7. Divide by 3. So we get x equals negative 7 over 3. Over here, if I add 7, I get 3x equals 7. Then I divide by 3. I get x equals 7 over 3. So these are the two solutions we get from number 37. Okay, that really is the last problem. I hope this was helpful to you. Thanks for watching, and make sure you watch the next one. Please make sure you were not copying. Shame on you if you were. Now the domain. The domain, again, is the x values, so it's how far left and right the graph goes. This graph goes left forever and right forever. So the domain will be negative infinity to positive infinity. Okay, the range. The range is the y values of the graph, bottom to top. Well, this graph goes down forever and up forever. So that's another negative infinity to positive infinity. Now the end behavior. On the left it rises, on the right it falls. So we will write that this way. As x approaches negative infinity, in other words, on the left, f of x approaches positive infinity. Okay, that means it rises. So on the left, it rises. And then we'll say as x approaches positive infinity, f of x approaches negative infinity. All right, that means as we go to the right, it falls. Okay, that's the going to the right, and that's falling. Now, find f of 1. Again, this is an x value in there, so go to an x value of 1 and look around. Well, if I go to 1, the graph is right here at 0. Okay, so f at 1 is 0. As an ordered pair, that would be 1 comma 0. Find f at negative 1. Okay, if I go to negative 1 and look around, bam! At negative 1, the function is here at 2. So So that means f at -1 equals 2. Or as an ordered pair, I could say -1 is matched up with 2. Okay, now the zeros of the graph. The zeros come from the x-intercepts. You look at the x-intercepts for the zeros, but you do not write an ordered pair. If it's zeros, they're just numbers. Okay, so the zeros are here and here. But for zeros, we do not make an ordered pair. So we will just say -2 and 1. Those are the zeros. All right, no ordered pairs. Now, y-intercept is always an ordered pair. So here's my y-intercept, 0, 4. Absolute maximum. Is there a point that is the absolute highest point on the graph? No. There is no absolute maximum because this graph goes up forever. All right, what about an absolute minimum? Is there an absolute minimum? Is there an absolute lowest point on this graph? Again, no. This graph goes down and down and down forever, so there is no lowest point. So absolute minimum, none. Now, how about a relative maximum? Okay, a relative maximum, it's not the highest point on the entire graph, but it's the top of its own little hill. And here's a relative maximum right here. Okay, it's not the highest point on the graph because like these points over here are higher, but it is the highest point in this area. So that is the point 0, 4. So yes, I have a relative maximum, 0, 4. What about a relative minimum? Do you see one of those? Yeah, there's a relative minimum right here. All right, it's the lowest point on the valley here. So that's -2, 0. All right, if this had been the lowest point overall, I would have called it the absolute minimum, not the relative minimum. Okay, now we're going to look at the increasing intervals and the intervals of decreasing. Increasing. Okay, so I'm going to draw this on the picture. I feel like I already did this. Didn't I already do this? Oh, you know, did I do the... oh, what an idiot. Okay.